This is the demo of fault isolation using UDP probe with in-band OAM. Currently in a data center network, ping and trace routes are used to detect failures and isolate the problems in the network. This method is very slow and it takes tens of seconds in a large network. So the objective is to improve the failure detection and isolation times. Using UDP probe with in-band OAM, we can detect the failures in a much faster way and isolate the failure to a node or a link. This shows the working of UDP probe. Here, node A is a pinger and B is a responder which is connected over a IP network. Node A sends out UDP probe packets with in-band OAM. By varying the UDP source and destination ports, we can cover all the paths possible between node A and node B. Each node in the network between A and B records its hop information, that is node ID, ingress interface, egress interface, timestamp of the packets passing through. On receiving the probe packet, B changes the source and destination of the packet and sends it back to the pinger. So once A receives back the probe response, we can use it to analyze the packet to get the latency of the packet, measure the delay, jitter, and even the packet loss, and also to trace the path between node A and B. So this shows the failure isolation with in-band OAM using UDP probe. In this diagram, A is the pinger and F is the responder. Initially, packets from A to F are sent and received since there is no failure in the network. Let's say suppose there is a link failure between C and F. So A won't be receiving the response for the ping packets which are sent to the F. On detecting this, A sees that there is a failure in the network and begins the failure isolation logic. So A starts sending probe packets with loopback flag set. So on receiving loopback flag packets, the intermediate nodes B and C will forward the packet and as well send a copy back to the source A. So with this, A receives a loopback response from node B and node C, not from F. With this, A concludes that there is a link failure between node C and F. This shows a typical data center network in which we can use UDP probe with in-band OAM to detect the faults and isolate them. So using UDP probe, we can detect the complete node bar link failures or the partial losses using the sequence number within in-band OAM. This is the demo topology which we will use in Viral to showcase in-band OAM fault detection. So this is a typical data center network in which we have rack switches which host the server software running, and we have fabric switches at the next level which provide connectivity within the same cluster, and we have spine switches which provide the connectivity across the clusters. This is the one of the VPP node rack switch 1 on which we have configured UDP probe sessions to all other rack switches. Show UDP ping summary is the command using which we can see the status of the UDP ping sessions. So as you can see, the source IP is db00::1. This is the local IP and this is the IP address of the rack switch 2. Source port range used is 5000 to 5003 and destination port range is 6000 to 6003. So UDP probe sessions will be sent for all combination of source and destination ports. So for example, for source port 5000 and destination port 6000, currently the path state is up, and as we can see the path map, the path taken by this session is through node 1 to node 5 to 2 and then to 6 and back to 1. And it also shows records the ingress interface and egress interface. Also, we can see that we have sequence number data which shows the number of packets lost in the network. Similarly, we have the data for all other port combination here. This is the front-end UI which shows the network topology discovered using UDP probe. We have configured UDP probe between all the rack switches so that it covers the entire network including all links and all nodes. So now I'm going to disable one of the links here and showcase how network topology is reflected. So I'm disabling the link between spine switch 1 to fabric switch 4. Also I'm disabling the link between spine switch 2 to fabric switch 1. So already one link failure is detected and now we have both the link failures detected. Now if I go back and remove the failure, then we should see that the link should come back up. I'm removing the failure on the other link also. One link failure is cleared. And now other link failure is also cleared. So that concludes this demo. Thank you.